Before we dive into this extraordinary story, if you enjoy detailed historical accounts that reveal untold stories from World War II, please subscribe to our channel and hit the notification bell so you never miss our in-depth documentaries. In the desperate final years of the Pacific War, Japanese engineers and pilots undertook a mission that would forever change their understanding of American air power. When a heavily damaged B-17E Flying Fortress made an emergency landing on Japanese-controlled Java in February 1943, it became the first intact American heavy bomber to fall into enemy hands. What followed was an intensive evaluation program that would strip away Japanese confidence and reveal the staggering technological gap between the two nations. This is the story of how Japanese test pilots flew the legendary Flying Fortress, how their admiration turned to dismay, and how this single captured aircraft exposed the brutal reality that Japan's aerial war machine could never match the range, payload, and engineering sophistication of American strategic bombers. It's a tale of technical espionage, grudging respect, and the harsh lessons learned too late in a war already slipping beyond reach. Before we dive into this extraordinary story, if you enjoy detailed historical accounts that reveal untold stories from World War II, please subscribe to our channel and hit the notification bell so you never miss our in-depth documentaries. The dawn broke cold over Bandung Airfield on Java Island, February 19, 1943, casting long shadows across the tarmac where a strange and magnificent prize sat surrounded by armed guards and clusters of excited Japanese aviation personnel. The aircraft was a Boeing B-17E Flying Fortress, serial number 412446, bearing the scars of brutal combat and an emergency landing that had brought it into Japanese hands just days earlier. For the engineers and pilots gathered around this massive four-engine bomber, it represented something more valuable than gold. It was a window into American industrial capability and a chance to understand the weapon that had been hammering Japanese positions across the Pacific with impunity. The B-17E had departed from Port Moresby, New Guinea on February 14, 1943, as part of a bombing mission against Japanese shipping in the Makassar Strait. The crew belonged to the 63rd Bombardment Squadron, 43rd Bombardment Group, 5th Air Force, and their mission that day was to interdict Japanese naval movements supporting operations in the Dutch East Indies. The aircraft had been piloted by First Lieutenant Earl Rogge, with Second Lieutenant Charles Colwell as co-pilot, and a full crew of 10 men including navigators, bombardiers, radio operators, and gunners. The mission proceeded normally until they encountered intense anti-aircraft fire over their target area. Japanese defenders, growing increasingly proficient at engaging high-altitude bombers, managed to score several direct hits on the B-17E. Shrapnel tore through the fuselage, severing hydraulic lines and damaging one of the engines. Smoke began pouring from the No. 3 engine, and the aircraft started losing altitude rapidly. Lieutenant Rogge fought to maintain control as the aircraft shuddered and bucked, but it was clear they could not make it back to Port Moresby. The crew faced a desperate choice: bail out over enemy territory or attempt an emergency landing and hope to destroy the aircraft before capture. Rogge made the difficult decision to attempt a landing, hoping to get the crew down safely and then demolish the bomber with thermite, grenades, and gunfire to prevent it from falling into Japanese hands intact. The crippled B-17E descended through tropical clouds, losing precious altitude with each passing minute. The crew jettisoned everything they could to reduce weight, including ammunition, personal equipment, and even their boots. Through breaks in the cloud cover, they spotted what appeared to be a suitable landing area near Bandung on Java, which, unknown to them, was already under firm Japanese control. The landing was harrowing but successful. Rogge brought the massive bomber down in a field adjacent to a road, and despite the rough terrain and the aircraft's damaged condition, the B-17E came to rest relatively intact, with its main structure and 3 of its 4 engines still functional. But before the crew could carry out their demolition plan, Japanese troops who had witnessed the landing rushed to the site. The Americans found themselves immediately surrounded by dozens of armed soldiers. Within minutes, the entire crew was taken prisoner, and Japanese engineers were already examining their prize. The capture of an intact B-17E represented an intelligence windfall of the first magnitude for the Japanese military throughout 1942 and into 1943. B-17s had been conducting raids against Japanese installations across the Pacific, and Japanese fighter pilots had found them exceptionally difficult to shoot down. The aircraft's reputation for ruggedness, heavy defensive armament, and ability to absorb tremendous punishment had made it a legend on both sides of the conflict. Now Japanese engineers would have the opportunity to examine every rivet, every system, and every innovation that made the Flying Fortress such a formidable weapon. Within hours of the capture, orders came down from Imperial General Headquarters in Tokyo. The B-17E was to be carefully transported to a secure facility, thoroughly examined, repaired if possible, and tests flown by Japanese pilots. The goal was threefold. First, to understand the technical specifications and capabilities of the aircraft. Second, to identify weaknesses that could be exploited by Japanese fighter pilots. And third, to evaluate whether any of the B-17's design features could be incorporated into Japanese aircraft development programs. The bomber was carefully moved to Bandung Airfield, where a team of engineers from the Koku Jujutsusho, the Air Technical Arsenal, began a meticulous examination. They photographed every component, measured every dimension, and documented every system. The Wright R-1820 Cyclone engines were studied with particular interest, as were the Sperry bomb sight, the oxygen systems for high-altitude operations, and the defensive armament arrangement. Japanese engineers marveled at the attention to crew comfort and safety features. The heated, pressurized crew compartments seemed almost luxurious compared to Japanese bombers, where crews often suffered from frostbite and oxygen deprivation at high altitudes. The armor protection for crew positions, the self-sealing fuel tanks, and the redundant systems all spoke to an approach to aircraft design that prioritized crew survivability in ways that Japanese doctrine largely ignored. One of the engineers, Captain Takeshi Kawamura, a veteran of aircraft evaluation programs, later recorded his impressions in a technical report. He wrote that the B-17E demonstrated a level of engineering sophistication and manufacturing precision that was sobering to contemplate. Every component showed evidence of mass production techniques and quality control standards that far exceeded Japanese capabilities. The aluminum alloys used in the airframe were of superior quality to anything Japan could produce domestically. The electrical systems were more robust and reliable than their Japanese equivalents. Even small details like the quality of the paint, the precision of the instrument calibration, and the ergonomic design of crew stations revealed a staggering disparity in industrial capacity. But the real revelation would come when Japanese pilots actually flew the B-17E. After nearly 3 weeks of repairs and preparation, the bomber was declared airworthy in early March 1943. The Japanese had managed to repair the damaged engine, replace hydraulic lines, and restore most of the aircraft's systems to operational status. They repainted the bomber in Japanese markings, removing the American star insignia and replacing it with the red circular Hinamaru of the Imperial Japanese Forces. A special test pilot team was assembled for the evaluation flights. The lead pilot was Commander Tsuyoshi Hattori, an experienced naval aviator who had flown everything from fighters to large flying boats. His co-pilot was Lieutenant Masahiko Shimizu, and they were supported by a full crew of Japanese engineers and aviation specialists who would monitor and document every aspect of the aircraft's performance. On March 8, 1943, Commander Hattori and his crew climbed aboard the captured B-17E for their first evaluation flight. The American bomber dwarfed the Japanese aircraft parked nearby. Even sitting on the ground, the B-17 projected an aura of power and purpose that was impossible to ignore. Hattori settled into the pilot's seat, which had been designed for American proportions and felt almost comically spacious. The instrument panel stretched before him, displaying more gauges and controls than any Japanese bomber possessed. The cockpit was arranged with logical efficiency, with every control within easy reach and clearly labeled. After running through an extensive pre-flight checklist, Hattori started the 4 Wright Cyclone engines one by one. Each engine roared to life with a deep, powerful sound that vibrated through the entire airframe. The engines ran smoothly at idle, demonstrating reliability that Japanese engines rarely matched. Hattori advanced the throttles for takeoff, and the B-17E began rolling down the runway. Despite its weight of over 40,000 pounds fully loaded, the bomber accelerated smoothly and lifted off after what seemed like a remarkably short ground run. As the landing gear retracted and the aircraft climbed away from Bandung, Hattori began to understand what his country was truly facing. The flight characteristics of the B-17E impressed the Japanese test crew immediately. The aircraft was stable and responsive, with control forces that were lighter than expected for such a large bomber. The visibility from the cockpit was excellent, with large windows providing clear sight lines in all directions. The aircraft climbed steadily to 25,000 feet, an altitude that represented the operational ceiling for most Japanese bombers, but which the B-17 reached with power to spare. At altitude, Hattori put the bomber through a series of maneuvers designed to test its handling characteristics. The B-17E responded smoothly to control inputs, maintaining stability even during aggressive turns and altitude changes. The aircraft could be flown accurately with minimal effort, and the control harmony between ailerons, elevators, and rudder was nearly perfect. Japanese bombers, by contrast, often required constant attention and physical effort to maintain stable flight, especially at high altitudes. Lieutenant Shimizu, monitoring the engines and systems, was equally impressed. The 4 Wright Cyclones ran with remarkable smoothness, maintaining consistent power output without the fluctuations and roughness that plagued Japanese radial engines. The fuel consumption was predictable and efficient. The hydraulic systems operated flawlessly, and the electrical generation capacity exceeded anything available in Japanese aircraft. But it was when they examined the bomber's range and payload capabilities that the true disparity became apparent. The Japanese crew reviewed the technical documentation that had been captured with the aircraft, including the aircrew operating manual and performance charts. The numbers were staggering and frankly demoralizing. The B-17E had a maximum range of approximately 2,000 miles with a 4,000-pound bomb load. With reduced bomb loads, the range could be extended to over 3,000 miles. The aircraft could carry up to 4,400 pounds of bombs in its internal bomb bay, with provisions for additional external racks if needed. It could operate effectively at altitudes exceeding 35,000 feet, well above the effective ceiling of most Japanese interceptors. The defensive armament consisted of 8 to 13 50-caliber machine guns depending on the specific configuration, providing overlapping fields of fire that made the B-17 exceptionally difficult to attack successfully. Commander Hattori compiled his observations into a detailed report that would shake the confidence of Japanese military leadership. He wrote that the B-17E represented a quantum leap in strategic bombing, capability that Japan simply could not match. The largest Japanese bomber then in service, the Mitsubishi G4 Mbeiti, had a maximum range of approximately 1,800 miles and could carry only 1,760 pounds of bombs at that range. Japanese bombers typically operated with ranges of 1,000 to 1,500 miles, carrying bomb loads of 800 to 2,000 pounds. None could match the B-17's combination of range, payload, altitude performance, and defensive armament. The implications were profound and disturbing. American B-17s operating from bases in Australia and New Guinea could strike targets across the entire Southwest Pacific with impunity. Japanese fighters struggled to reach the altitudes where the B-17s operated most effectively, and even when they succeeded in intercepting the American bombers, the concentrated defensive fire from formations of flying fortresses exacted a terrible toll on attacking fighters. The B-17's ability to absorb battle damage and return to base, thanks to its rugged construction and redundant systems, meant that even successful attacks often failed to bring down the bombers. Hattori's report went further, analyzing the implications for Japan's strategic situation. He noted that the B-17E represented only one type of American heavy bomber, and that newer models with even greater capabilities were undoubtedly under development. The industrial capacity required to produce such sophisticated aircraft in quantity was staggering. Each B-17 required approximately 400,000 man-hours to manufacture, employed precision machinery and skilled labor on a massive scale, and consumed quantities of aluminum, steel, rubber, and other strategic materials that Japan could barely imagine, let alone replicate. The United States was producing B-17s at a rate of dozens per month, with production accelerating. Japan, meanwhile, struggled to maintain production of far simpler aircraft types and constantly battled shortages of materials, skilled labor, and manufacturing capacity. The message was clear. In the realm of strategic air power, Japan was hopelessly outmatched. The Japanese test program continued for several more months. Additional flights were conducted to evaluate the B-17E under various conditions and configurations. Japanese pilots practiced interception tactics, approaching the bomber from different angles to identify the most vulnerable attack approaches. They discovered what American crews already knew. The B-17 had few blind spots in its defensive coverage, and attacking from almost any angle meant flying through a gauntlet of .50 caliber fire. The most effective tactic appeared to be head-on attacks, where the interceptor presented a small target and could exploit the relatively lighter forward armament of the B-17E model, but this required exceptional piloting skill and nerves of steel. As the closing speed between fighter and bomber was extremely high and the window of opportunity to fire effectively was measured in fractions of a second, Japanese engineers also attempted to study the aircraft's manufacturing methods. But here they encountered a frustrating reality. The B-17 had been built using mass production techniques, precision tooling, and quality control standards that Japanese industry could not duplicate. The aluminum alloys in the airframe required smelting and processing capabilities that Japan lacked. The precision instruments and complex systems depended on components manufactured to tolerances that Japanese factories struggled to achieve consistently. Even the tires, seemingly simple components, were made from synthetic rubber compounds that Japan could not produce in sufficient quantities. One particularly telling observation came from an engineer named Akira Nakamura, who had studied aeronautical engineering in the United States before the war. He noted in his report that the B-17E embodied not just superior technology but an entirely different philosophy of aircraft design. American engineers designed aircraft to be manufactured in quantity, maintained in field conditions, and operated by crews with varying skill levels. Every system had backups, every component was made to be replaced rather than repaired, and the entire aircraft was designed around the principle that crew survivability and mission completion were more important than squeezing out the last ounce of performance. Japanese aircraft design, by contrast, emphasized performance above all else, often sacrificing durability, maintainability, and crew protection in pursuit of speed, range, or maneuverability. This philosophy produced some exceptional aircraft for specific roles, but it also resulted in bombers that were vulnerable to damage, difficult to maintain, and demanding to fly. The captured B-17E highlighted these philosophical differences in stark terms. During one evaluation flight in late March 1943, Commander Hattori pushed the B-17E to its limits to test its structural strength. He performed steep turns, rapid altitude changes, and high-speed dives that would have torn apart most Japanese bombers. The B-17E absorbed these stresses without complaint, its massive wings flexing but never approaching failure, its fuselage remaining solid and intact. Hattori reported that the safety margins built into the B-17 structure were enormous, giving crews confidence to push the aircraft when necessary without fear of structural failure. This robustness had a tactical significance that could not be overstated. B-17 crews could take evasive action when attacked, could fly through severe weather that would ground Japanese bombers, and could limp home with battle damage that would be fatal to less robust aircraft. The psychological impact on American crews of knowing their aircraft could take punishment and bring them home was immeasurable. Japanese bomber crews flying far more fragile aircraft knew that a single hit in the wrong place could doom them, and this knowledge affected their performance and morale. The Japanese evaluation program also included extensive study of the B-17's defensive armament. The 8.50 caliber Browning M2 machine guns mounted in various positions around the aircraft represented firepower that far exceeded anything on Japanese bombers. Each gun had a high rate of fire, excellent reliability, and fired a heavy projectile that could damage or destroy attacking fighters with just a few hits. The ammunition capacity for each gun was substantial, and the turrets allowed gunners to track targets effectively. Japanese bomber defensive armament typically consisted of 7.7mm or 13mm machine guns with limited traverse and relatively light hitting power. Japanese gunners often found themselves outranged by American fighters attacking with .50 caliber guns of their own, and the defensive fire from Japanese bombers was rarely sufficient to drive off determined attacks. The B-17, by contrast, could put up a wall of fire that made attacking it a hazardous proposition even for experienced fighter pilots. One of the most revealing tests conducted by the Japanese involved a mock combat scenario where Japanese fighters attempted to shoot down the captured B-17E. The exercise took place on April 15, 1943, at an altitude of 22,000 feet over the Java Sea. 3 experienced fighter pilots flying Nakajima Ki-43 Oscar fighters were tasked with intercepting and attacking the B-17, which was crewed by Japanese personnel simulating defensive gunners. The rules of engagement called for the fighters to make actual attack runs, though of course without live ammunition. The results were sobering for the fighter pilots. Despite knowing exactly where the B-17 would be, having ideal weather conditions, and facing gunners who were not experienced B-17 crew members, the Japanese fighters found it extremely difficult to set up effective attacks. The B-17's speed at altitude was higher than expected, making it challenging to overtake. The aircraft's defensive fire zones overlapped so completely that there was no approach that did not expose the attacker to multiple guns. The fighters made repeated passes, but the pilots reported that in actual combat with real gunners and the possibility of being hit, the risk would be extreme. They estimated that successfully bringing down a lone B-17 would likely require coordinated attacks by at least 5 or 6 fighters, and even then, losses among the attackers would be heavy. When the B-17 flew in formation with other bombers, as was standard American practice, the concentrated defensive fire from multiple aircraft made successful attacks far more costly. After the mock combat exercises, one of the fighter pilots, a young lieutenant named Saburo Yoshida, wrote a letter to a friend that was later discovered in captured documents. He wrote candidly about his experience attacking the B-17, describing it as one of the most intimidating aircraft he had ever faced. He noted that the psychological impact of approaching a B-17 while seeing its guns tracking you was significant, even in a training scenario. In actual combat, knowing that those guns were firing explosive and armor-piercing rounds at 800 rounds per minute would require tremendous courage. He concluded that the Americans had created a bomber that could defend itself effectively, and that Japan had nothing comparable. The Japanese test program with the captured B-17E continued through the spring and early summer of 1943. In total, the aircraft was flown approximately 40 times by various Japanese pilots and crew members. Each flight provided additional insights into the capabilities and limitations of the Flying Fortress. Japanese intelligence officers interrogated the captured American crew members, hoping to gain operational information about B-17 tactics, formations, and procedures. The Americans provided only name, rank, and serial number as required by the Geneva Convention, but some information could be gleaned from technical manuals and documents captured with the aircraft. By July 1943, the Japanese had extracted everything they could learn from the captured bomber. A comprehensive report was compiled and distributed to senior military and aviation officials throughout the Japanese armed forces. The report's conclusions were unambiguous and deeply discouraging. It stated that the Boeing B-17 Flying Fortress represented a strategic bombing capability that Japan could not match with existing aircraft and could not hope to develop and produce in time to affect the outcome of the war. The report noted that American bomber production was accelerating dramatically, with new models featuring even greater capabilities. The B-17E they had captured was already being superseded by the B-17F and B-17G models with improved performance and heavier armament. Meanwhile, the United States was also producing other heavy bombers, including the consolidated B-24 Liberator, which had comparable range and payload to the B-17. The combined output of American heavy bomber production dwarfed Japan's entire military aircraft manufacturing capacity. The report recommended that Japan focus on developing more effective interceptor tactics and aircraft specifically designed to counter high-altitude bombers. But it acknowledged that the fundamental problem was one of industrial capacity rather than technical knowledge. Japan lacked the aluminum production, the precision manufacturing capability, the electronics industry, and the skilled labor force necessary to match American aircraft production. The war in the air was being decided not just by pilot skill or tactical innovation, but by sheer industrial might, and in this contest, Japan was hopelessly overmatched. The captured B-17E met its end in September 1943. By this time, American forces were advancing across the Pacific, and the security of the Bandung facility became questionable. Rather than risk the bomber falling back into American hands, Japanese authorities ordered it destroyed. The B-17E was stripped of all useful components, doused with gasoline, and burned. Its charred remains were later bulldozed into a disposal pit, ending the career of an aircraft that had served, however briefly, on both sides of the Pacific War. But the lessons learned from the captured B-17E continued to reverberate through the Japanese military establishment. The evaluation had stripped away illusions and revealed uncomfortable truths about the technological and industrial gap between Japan and the United States. Japanese engineers and military planners now understood that they were fighting an enemy whose economic and industrial capacity exceeded their own by an order of magnitude. This knowledge did not change Japan's determination to continue the war, but it did inform their understanding of what they faced. In the years following the capture and evaluation of the B-17E, Japan attempted to develop longer-range bombers with greater payload capacity. Programs were initiated to design aircraft that could strike targets across the Pacific or potentially reach the American mainland. The Nakajima G-8N, Renzin, and the Fugaku project represented attempts to create strategic bombers comparable to American types. However, these programs were hampered by the same industrial limitations that the B-17 evaluation had exposed. Chronic shortages of materials, inadequate manufacturing facilities, and the diversion of resources to more pressing needs meant that these advanced bomber projects never progressed beyond prototype stages or remained purely on paper. Meanwhile, American B-17s continued to hammer Japanese positions throughout the Pacific. By 1944, B-17s were conducting regular raids against targets in the Philippines, Formosa, and even the Japanese home islands. The bombers operated from bases in China, India, and the Marianas, exploiting their long range to strike deep into Japanese-controlled territory. Japanese fighter pilots found themselves facing formations of B-17s numbering in the dozens or even hundreds, escorted by long-range fighters and protected by their own concentrated defensive fire. The tactics that Japanese pilots developed to counter B-17s were born from the evaluation program that began with the captured aircraft in Java. They learned to attack from head-on, to target engines and cockpit areas, and to make coordinated attacks that overwhelmed the bomber's defensive capabilities. They developed specialized interceptors with heavy forward-firing armament designed specifically for bomber destruction. But these tactics and aircraft came too late and in too few numbers to significantly impact the strategic bombing campaign that was systematically destroying Japan's ability to continue the war. Some of the Japanese pilots and engineers who had participated in the B-17E evaluation program survived the war and later shared their recollections with historians. Commander Hattori, who had flown the captured bomber, was interviewed in the 1960s about his experience. He spoke candidly about the revelation that flying the B-17 had provided. He described the aircraft as representing everything Japan lacked: industrial sophistication, manufacturing precision, abundant resources, and a design philosophy that valued crew survival and mission success over abstract notions of honor or minimal sufficiency. He noted that Japanese military culture emphasized doing more with less, making up for material deficiencies with spiritual strength and fighting spirit. But flying the B-170 had made clear to him that there were limits to what courage and determination could achieve when facing an enemy with overwhelming material superiority. Hattori recalled that after his evaluation flights, he had written a personal letter to a senior admiral describing what he had learned. He had stated bluntly that Japan could not win an extended war against the United States because the industrial and economic foundations for victory simply did not exist. He received no response to his letter, and the war continued for another 2 years, eventually ending in Japan's complete defeat. Looking back decades later, Hattori expressed no bitterness, only a kind of melancholy understanding that the outcome had been inevitable once the full weight of American industrial power was brought to bear. The story of the captured B-17E also provides insight into the broader dynamics of the Pacific War. Japan began the war with tactical advantages: better trained pilots, combat experience from operations in China, and aircraft designed for the specific conditions of Pacific warfare. These advantages yielded spectacular successes in the first months of the war. But as the conflict extended beyond the quick victory that Japanese planners had expected, the fundamental advantages of the Allied powers began to manifest. The United States could replace losses in aircraft and trained crew at rates that Japan could never match. American aircraft design improved continuously, with new models incorporating lessons from combat experience. American pilots received extensive training in safe conditions with ample fuel and resources. The logistical infrastructure supporting American air operations was vast and sophisticated. In contrast, Japan watched its advantages erode. Experienced pilots were lost and could not be adequately replaced because training programs were inadequate and fuel shortages limited flight hours for novice pilots. Aircraft production never met demand, and newer designs often failed to enter service in meaningful numbers. The logistical system struggled to supply forward bases with necessary materials. The technological gap already present at the war's widened continuously as American innovation and production accelerated while Japan stagnated. The captured B-17E represented in microcosm this broader dynamic. It was a symbol of American power, a harbinger of the aerial onslaught that would eventually reduce Japanese cities to ash, and a testament to an industrial capacity that Japan had fatally underestimated. The Japanese pilots and engineers who flew and examined the B-17 understood these implications immediately. Their reports circulated through military channels, read by officers who could not help but recognize the grim reality they revealed. Yet the war continued because institutional momentum, cultural factors, and political realities made accepting defeat unthinkable until overwhelming force made further resistance impossible. Another dimension of the captured B-17 story involves the fate of the American crew members. Lieutenant Rogge and his crew became prisoners of war and were transported to POW camps where they spent the remainder of the war under harsh conditions. The Japanese military sometimes treated captured air crews who had bombed Japanese positions particularly severely, regarding them as war criminals rather than legitimate prisoners of war. Some of Rogge's crew members were interrogated extensively about B-17 operations, tactics, and technical details. The men resisted providing information beyond what was required by the Geneva Convention, but their captors sometimes used coercion and deprivation to pressure them. Several crew members became ill due to poor conditions and inadequate medical care. Despite these hardships, all 10 crew members of the captured B-17E survived the war and were liberated when Japan surrendered in August 1945. They were repatriated to the United States, where they underwent debriefing about their capture and imprisonment. Lieutenant Rogge later learned about the extensive evaluation program that the Japanese had conducted on his aircraft. He expressed mixed feelings about the fate of his bomber. On one hand, he regretted that it had not been successfully destroyed before capture, as this would have denied valuable intelligence to the enemy. On the other hand, he acknowledged that the aircraft's capture had likely saved his crew's lives, as bailing out over enemy territory or attempting to reach neutral territory would have been far more dangerous than the controlled landing that brought them down intact. In post-war years, aviation historians have extensively studied the Japanese evaluation of captured American aircraft. The B-17E was not the only American aircraft to fall into Japanese hands during the war, but it was among the most significant captures due to its role as a strategic bomber. Japanese records document evaluations of captured P-40 fighters, P-38 fighters, and other types. all of which provided insights into American aviation technology. However, the B-17E evaluation stands out for the comprehensive nature of the testing program and the strategic implications of the findings. Documents from the evaluation were captured by American forces after the war and have since been translated and analyzed. The technical reports compiled by Japanese engineers provide fascinating details about their testing methodology and conclusions, inviolable for their objectivity and thoroughness. Japanese engineers did not attempt to minimize the B-17's capabilities or exaggerate its weaknesses. Instead, they provided frank assessments that clearly communicated the aircraft's strengths and the challenges it posed to Japanese defenses. These reports circulated at high levels within the Japanese military, and their findings influenced decisions about resource allocation, aircraft development priorities, and defensive strategies. The broader context of strategic bombing in World War II also illuminates the significance of the captured B-17E. The concept of using heavy bombers to strike deep into enemy territory, destroying industrial capacity, transportation infrastructure, and military installations, represented a fundamental shift in warfare. The B-17, along with aircraft like the B-24 Liberator and later the B-29 Superfortress, embodied this strategic bombing doctrine. These aircraft could carry substantial bomb loads over great distances, operate at altitudes that made interception difficult, and defend themselves against fighter attack. Japan never fully embraced strategic bombing doctrine, partly because of limitations in industrial capacity, and partly because of doctrinal emphasis on naval aviation and tactical air support. Japanese bombers were designed primarily to support naval operations, attack ships, and provide tactical support to ground forces. The concept of a dedicated strategic bombing campaign against enemy industrial centers was less developed in Japanese military thinking. This doctrinal difference reflected the different circumstances and strategic priorities of the two nations. Japan was fighting a war across a vast oceanic theater where naval power was paramount. The United States had the industrial capacity to pursue multiple strategic objectives simultaneously, including a massive strategic bombing campaign that sought to destroy the enemy's ability to continue the war by eliminating industrial production. The captured B-17E thus represented not just a specific aircraft but an entire approach to warfare that Japan had not fully embraced and could not effectively counter. As the war progressed and American strategic bombing intensified, Japan attempted to develop effective countermeasures. New fighter designs with heavy armament appeared, such as the Kawasaki Ki-45 Toryu and specialized high-altitude interceptors. Tactics evolved to focus on disrupting bomber formations before they reached their targets. Anti-aircraft artillery defenses were strengthened around critical installations, but these measures proved insufficient against the scale and persistence of American bombing operations. By 1945, formations of B-29 Superfortresses, which made the B-17 seem almost modest by comparison, were systematically destroying Japanese cities with incendiary attacks. The strategic bombing campaign, combined with naval blockade and conventional military advances, strangulated Japan's ability to continue the war. In retrospect, the evaluation of the captured B-17E in early 1943 had provided an early warning of what was to come. The Japanese officers who read the evaluation reports could see clearly that their nation faced an enemy with overwhelming advantages in industrial capacity, technological sophistication, and strategic resources. Some officers advocated for seeking a negotiated peace, while Japan still held some bargaining chips. Others argued for redoubling efforts to develop countermeasures and new weapons that might offset American advantages. The dominant view, however, held that Japan must continue fighting regardless of the odds, trusting in the courage of its people and the righteousness of its cause. This determination persisted until two atomic bombs and the Soviet entry into the war finally forced acceptance of unconditional surrender. The legacy of the captured B-17E extends beyond its immediate impact on Japanese military assessments. The aircraft represents a broader historical pattern where superior industrial capacity proves decisive in modern warfare. The Pacific War demonstrated that tactical brilliance and fighting spirit, while important, cannot overcome fundamental disadvantages in resources and production capability. The United States entered World War II with enormous latent industrial strength that, once mobilized, produced weapons and materiel in quantities that overwhelmed all enemies. The B-17 Flying Fortress was one of the premier products of this industrial mobilization. Over 12,000 B-17s of all models were produced during the war, an achievement that reflected not just manufacturing capacity but also the sophisticated supply chains, skilled workforce, and technological infrastructure necessary to produce such complex machines in quantity. Each B-17 required thousands of components sourced from suppliers across the country, assembled by workers trained in specialized techniques, and tested to rigorous standards before delivery. This industrial ecosystem was something Japan could observe and document through captured examples, but could never replicate. The Japanese pilots who flew the captured B-170 in the skies over Java in 1943 experienced firsthand the capabilities of an aircraft that represented American industrial might. Their detailed reports to superiors made clear that Japan was fighting an enemy whose material resources were effectively unlimited compared to their own. This knowledge did not alter the course of the war, which continued for more than 2 years after the B-170 evaluation, but it provided a clear-eyed assessment of reality for those willing to see it. Some Japanese officers understood the implications immediately and recognized that victory was impossible. Others clung to hopes that determination and sacrifice might yet produce a favorable outcome. All, however, had to acknowledge that the B-17 and aircraft like it represented a class of weapon that Japan could not match. In the post-war period, surviving Japanese aviation engineers and pilots often reflected on the lessons learned from encounters with American aircraft. Many expressed admiration for American engineering approaches that emphasized reliability, maintainability, and crew survival. Some argued that Japan should have adopted similar philosophies earlier, prioritizing practical effectiveness over theoretical perfection. Others noted that Japan's resource limitations would have made such approaches impossible, regardless of philosophical inclinations. The debate continues among historians about whether different Japanese design choices or strategic decisions could have altered the war's outcome, but most scholars agree that the fundamental disparity in industrial capacity made Japanese defeat inevitable once the United States fully mobilized. The story of the captured B-170 thus serves as a case study in the relationship between industrial capacity, technological sophistication, and military effectiveness. It demonstrates how superior equipment can provide decisive advantages in combat and how understanding your opponent's capabilities is crucial for realistic strategic planning. It also illustrates the limitations of technology transfer and reverse engineering when the underlying industrial infrastructure necessary to produce comparable equipment does not exist. Japan could examine and admire the B-17, but could not build a comparable aircraft because the entire industrial ecosystem required for such production was absent. As we conclude this detailed examination of how Japanese pilots flew a captured B-17 Flying Fortress and came to recognize the unbridgeable gap in strategic bombing capabilities, several themes emerge. First, the technical excellence of the B-17 reflected not just good design but an entire industrial philosophy that prioritized mass production, reliability, and crew survivability. Second, the Japanese evaluation program was thorough and professional, providing honest assessments rather than wishful thinking. Third, the lessons learned from the captured bomber confirmed what perceptive Japanese officers already suspected, that their nation was engaged in a war it could not win against an enemy with vastly superior resources. Finally, the story demonstrates the human dimension of war, where individuals on both sides recognized professional excellence even in their enemies, and where technical understanding transcended the passions of conflict. The American crew members who were captured when their bomber made that emergency landing in February 1943 could not have imagined that their aircraft would become the subject of such intensive study or that Japanese pilots would gain such respect for the machine they had flown. Similarly, the Japanese pilots and engineers who evaluated the B-170 and compiled their sobering reports were simply doing their duty, providing accurate information to their superiors even when that information conveyed uncomfortable truths. The B-17 Flying Fortress earned its legendary status through combat performance that validated its design principles. It could fly high, far, and with heavy loads. It could absorb battle damage and bring crews home. It could defend itself effectively against a fighter attack. Japanese pilots who engaged B-17s in combat, and those who flew the captured example in evaluation tests, all came to recognize these capabilities. Their admissions that no Japanese bomber could match the B-17's 2,000-mile range and 4,400-pound payload capacity were not expressions of defeatism but acknowledgments of reality. Wars are won not just by bravery and skill but by ships, tanks, aircraft, and supplies measured in quantities that reflect industrial capacity. The Pacific War demonstrated this truth repeatedly, and the captured B-17E provided Japanese military leaders with an early, clear illustration of the forces arrayed against them. Thank you for watching this detailed exploration of an extraordinary chapter in World War II aviation history. If you found this account informative and engaging, please subscribe to our channel for more in-depth historical documentaries. Share this video with others who appreciate detailed military history, and leave your thoughts in the comments below. Your support helps us continue producing these comprehensive historical narratives. Until next time, this is the story of how captured technology revealed uncomfortable truths, and how professional military evaluations sometimes confirm what strategic wisdom already suspected. The B-17 Flying Fortress was indeed a fortress in the sky, and the Japanese pilots who flew it knew this better than anyone.